Hi students, as a part of engineering chemistry first unit, that is molecular structure and theories of bonding, today I am going to explain about molecular orbital energy diagram of nitrogen molecule. So before going to discuss the molecular orbital energy diagram of nitrogen molecule, first let me explain why molecular orbital energy diagram. That is, what is the purpose of drawing the molecular orbital energy diagram. The following are the purposes of drawing the molecular orbital energy diagram. The first purpose is making use of molecular orbital energy diagram of the molecules. We can get the molecular orbital configuration of the molecule. And second one is, with the help of molecular orbital energy diagram, we are going to get the information about bond order of the molecule. That is, whether the single bond exists between the two adjacent atoms in a molecule, or double bond exists between the two adjacent atoms in a molecule, or triple bond exists between the two adjacent atoms in a molecule. And as there is a inversely proportional relationship between bond order and bond length, and with the help of molecular orbital energy diagram, as we are getting the information about bond order, we are going to get the information about bond length also. Not only that, as the bond order is directly proportional to stability of the molecule, and as we are getting the information about the bond order with the help of the molecular orbital energy diagram, we are going to get the stability of the molecule also. Information about the stability of the molecule as well. Now, without wasting much time, let us dive into this particular topic, that is molecular orbital energy diagram of nitrogen molecule. Now, what is the atomic number of nitrogen? What is the atomic number of nitrogen? Before that, nitrogen molecule, right? So nitrogen molecule means it comprises two nitrogens. N2 is the nitrogen molecule. And what about the atomic number of each nitrogen? Atomic number of each nitrogen is 7. So since atomic number is 7 electrons will be a part of each nitrogen. 7 electrons will be a part of each nitrogen. Since 7 electrons are a part of each nitrogen, as there are 2 nitrogen in the nitrogen molecule, so totally it comprises 14 electrons. So nitrogen molecule comprise 14 electrons. Nitrogen molecule comprise 14 electrons. Right? And what is the electronic configuration of the nitrogen atom? Right? So, since the nitrogen molecule is a combination of the nitrogen atom, we have to discuss the electronic configuration of the nitrogen atom. What is the electronic configuration of the nitrogen atom? 1s2, 2s2 and 2p3. So, electronic configuration of nitrogen is 1s2, 2s2, 2s2, 2p3. 1s2, 2s2, 2p3, right? 1s2, 2s2, 2p3. Now, this is how we can draw the molecular orbital energy diagram of the nitrogen molecule. So, while drawing the molecular orbital energy diagram of any of the molecule, keep these two postulates of MOED in the mind. What is the first postulate of molecular orbital theory? The first postulate is atomic orbitals combine to form molecular orbital. This is the first postulate. And what is the second postulate of molecular orbital theory? The number of molecular orbitals formed is equal to number of atomic orbitals combined. Right? So, do remember students, while drawing the molecular orbital energy diagram of any of the molecule, we have to keep these two postulates in the mind. Right. So, on the left side, atomic orbital of the one nitrogen. On the right side, we have atomic orbital of another nitrogen, because it is a combination of the two nitrogens. So we are taking the atomic orbitals of one nitrogen on the left side and atomic orbitals of the second nitrogen on the right side. On the right side. Right? Now, let us try to fill the electrons in the atomic orbitals first. Atomic orbitals. So, atomic orbital of the first nitrogen or left-handed nitrogen. What is the electronic configuration of the single nitrogen? 1s2, 2s2, 2p3. That is, 2 electrons are a part of 1s atomic orbital. 2 electrons are a part of 2s atomic orbital, and 3 electrons are a part of 3 2p atomic orbitals. And it follows the Hertz rule, right? And according to the Hertz rule, the pairing won't takes place in the atomic orbital until or unless each and every atomic orbital is filled with 1 electron of the same energy, of the same energy level. So accordingly, 1, 2, 3. So this is the condition of one nitrogen atom, which is a part of the nitrogen molecule. Now coming to the atomic orbital of the second nitrogen, the same 1s2, 2s2, 2p3. So 1s2, 1s2, 2s2, 2p3. 2s2, 2p3. 1s2, 2s2, 2p3. So we have filled the electrons in each and every atomic orbital of the 2 nitrogen atoms which are a part of the nitrogen molecule. Nitrogen molecule. So what is the first postulate, student? The first postulate is, what is the first postulate of molecular orbital theory? Atomic orbitals combine to form molecular orbitals. And the number of molecular orbitals formed is equal to number of atomic orbitals combined. So here, 2 atomic orbitals, in fact, 2 1s atomic orbitals of 2 nitrogen atoms combine to form 2 molecular orbitals, that is, one is sigma 1s and sigma star 1s. 2 2s atomic orbitals of the 2 nitrogen of the nitrogen molecule combine to form 2 molecular orbitals, the 1s, sigma 2s and sigma star 2s. And 6, 1, 2, 3, 4, 5, 6, 6 atomic orbitals of 2 nitrogen atoms of the 2 of the nitrogen molecules combine to form 6 molecular orbitals. 1, 2, 3, 4, 5, 6. Because what the second molecular orbital postulate says, the number of molecular orbitals formed is equal to number of atomic orbitals combined. Okay, combined. So accordingly, we are going to that. Now what we need to do, students, we have to fill the 14 electrons in this molecular orbitals. In this molecular orbital, we need to fill 14 electrons. And here, if you talk about these 6 molecular orbitals, so pi 2px, pi 2py is in front of the sigma 2pz. That is, pi 2px, pi 2py will be in the forward when compared to the sigma 2pz. Whereas in the molecules like oxygen and the fluorine molecules, the sigma 2pz will be in front when compared to pi 2px, pi 2py. And what is the reason? I have explained very clearly in one of the video. That is, we have to follow one rule for filling the electrons for the molecules containing the electrons up to 14 electrons. That is, this pattern or this order we have to follow. And for filling the electrons in the molecular orbitals for the molecules containing more than 14 electrons, we have to follow another rule. So, why I have clearly explained in that particular video. So in order to get the information or the clear-cut information about this particular information, why the two orders are being maintained for filling the electrons in the molecular orbitals for the molecules containing 14 electrons and more than 14 electrons, please do watch the video, and the link of that particular video is provided in the description box. So now let us fill the 14 electrons in the molecular orbitals. So totally 14 electrons are there, students. So 1, 2, 3, 4. So do remember, filling of electrons always follows the 3 rules, just like filling of the electrons in the atomic orbitals, that is Auber principle, Pauli's exclusion principle, and Hund's rule. Hund's rule already I have said. What is Hund's rule? Hund's rule states that the pairing of electrons won't take place in the orbital until or unless each and every orbital is filled with the 1 electron of the same energy level. So 2 electrons, 4 electrons, 5, 6 electrons, 7, 8, 9, 10, 11, 12, 13, and 14. So you have to follow those 3 rules above: Pauli's exclusion principle and Hund's rule. We have to follow that. So accordingly, what is the molecular orbital electronic configuration? Molecular orbital electronic configuration for this molecule is, what is that, student? Sigma 1s2, next sigma star 1s2, next sigma 2s2, next sigma star 2s2, next pi 2p x2, next pi 2p y2, pi 2p x2, pi 2p y2, last sigma 2p z2. So we got the first information. So we are going to get, with the help of molecular orbital energy diagram, what sort of information you are going to get. First one is molecular orbital electronic configuration of that particular molecule. Second, we are going to get the information about bond order of the molecule. What is the bond order, students? Bond order equals to 1/2 NB minus Na equals to 1/2. What is NB? Number of electrons in the bonding molecular orbitals, and Na is number of electrons in anti-bonding molecular orbitals. And anti-bonding molecular orbitals is represented by star or denoted by star. Right, now let us count the number of electrons in bonding molecular orbitals. How many are there? So this is 1, 2 electrons, next 2 electrons, 4, 5, 6, 7, 8, 9 and 10. 2, 4, 5, 6, 7, 8, 9, 10. So totally 10 electrons are involved in bonding molecular orbital. And how many electrons are involved in anti-bonding molecular orbitals? It is denoted by star, right? So how many? 2 plus 2, 4. 4. So is equals to 1/2. So 10 minus 4 is equals to 6, which is 3. So what does it mean? Bond order equals to 3 means there are 3 bonds between the 2 adjacent nitrogen atoms in nitrogen molecule. So accordingly, the structure of nitrogen molecule is N triple bond N. N triple bond N. So we got the second information, that is bond order. And what is another information we are going to get? Stability of the molecule, right? And bond order is directly proportional to stability of the molecule. And bond order is more, bond order is 3. So definitely it is more stable molecule. And what is the relationship between bond order and bond length? Inverse relation, right? So as the bond order is more and as the bond length is inversely proportional to the bond order, definitely we can say that bond length in between the two adjacent nitrogen atoms in the nitrogen molecule is less. So with the help of the molecular orbital energy diagram, we are going to get the information about molecular orbital, electronic configuration of the molecule, bond order, bond length, and stability of the molecule. I hope you understood. Thank you, students.